When designing websites, one of the problems we're always up against is how fast it will load. And when we have lots of imagery on our website, it tends to load really slowly. And so we want to look today at some of the different types of imagery and image types that will help our page be as fast as it possibly can. And so we're going to look at JPEGs, PNGs, GIFs or GIFs if that's your thing, and SVGs. And we're also going to throw in a fifth called WebP. I've got this guide here, an excellent guide that talks about some of the differences between the file types, JPEGs, WebP, PNGs, GIFs, and SVGs. So JPEGs, again, are probably the most popular. They're used on most cameras and cell phones. They're going to be supported on all browsers. The problem is that they don't support any kind of animation or transparency. In animation, think of like your animated GIFs, right? And transparency is where we might have something like this illustration where we have this background line going through it. So we need to have a transparent background in this area to allow whatever we put it on top of to show through, right? Well, a JPEG is going to give us a white box rather than allow this line to go through. And so that's one of the problems we have with JPEGs. Again, these are best for photography. They're good for really big imagery with lots of colors. These also use what's called a lossy compression. And a lossy compression, as we kind of talk about here on the side, is where data is going to get lost. And it's typically because of the compression that's used for it. So I have an example here of these balloons. And these balloons have this kind of junk up through this area. I don't know if you guys see this. And it makes it look kind of blocky, kind of gives it this grid look. And these are what are called JPEG artifacts. And again, it's some of the leftover pixels when we compress down an image. And it allows for the image to be much smaller. However, it can sometimes make it look worse. So if you want to preserve those colors, we really have to use another file type. Now, one file type that's amazing is the WebP file type. The number one problem is that Safari, and I believe also some of the Microsoft browsers will not support this. And so it's not a good viable solution for websites that are going to be seen online, right? It does have some animation support. It does use lossy as well as lossless compression, so you can preserve all of the colors and make it look perfect if you wanted to. It's much smaller than JPEGs, which is also fantastic. So that's if you're using the lossless version. If we are going to use the lossy version, if we're going to use the lossless version, it is quite a bit larger in file size, but 26% smaller than PNGs. So let's talk about PNGs. PNGs come in two flavors, well, three flavors here, an 8 version, 24-bit, and 32. Now these are great because they do allow transparency to come through, but they do not allow animation. Depending on the type you use, it might limit you to 256 colors or to the millions of colors that JPEGs use, or even more. Typically you don't see a 32-bit. They tend to be a lot bigger in file size, but again allow that transparency. And GIFs, probably more known for their animated GIFs. They do allow transparency to come through, and they do allow the animation, but they are limited typically to 256 colors, and that can be a big problem. We'll compare these and find which are best for what here in a second. SVGs, on the other hand, these are graphics that are created with math. Okay, so think of a calculator where you could create a Bezier curve and different things, and you can see here some of these curves kind of drug out to create something that says SVG, right? Well, if it is a bunch of algorithms and equations to create an image, it's going to be significantly smaller in size. It also will it'll also be a little bit more difficult to build an image. Now, an image like this you could probably make in an SVG just fine, but if you were to take a photo, you probably could never make that into an SVG. And we call that the difference between those raster images and vector images. And raster images are literal pixels on the screen, right? The problem with the raster image is when we make it really big, it gets pixelated. With a vector image, we can make it really big, and because it's built on math, it will never lose its clarity. Think of like an equation, you know, if we said y equals x squared, we can plug in any value into x we want, and y will grow exponentially. Well, if these SVGs or vector graphics are built on math, then they can grow as big or as small as you want, and they never lose the quality, never get pixelated. So they're really great for that. They're also supported on all browsers. So when we look at this, JPEG typically are more lossy. They're going to have a higher color count. They're going to be smaller in file size, so the compression is really great, but they don't have animation or transparency, and they're clearly not vector. PNGs, these are not lossy, so they look really great. Because they're lossless, they tend to be really big on the file size. Not always. You can use a smaller file or a PNG 8, but typically they're going to be quite a bit larger. They're not vector. They do support transparency, but they don't have animation. A WebP file, again, can be both lossy and lossless. They're not vector. They do support transparency and animation, and probably have the best compression out there. And so they are the smallest. Well, not the smallest next to vectors, but you know, they're definitely small. SVGs will never lose their quality. They are vector. They do support transparency, and you can do animation with it as well, which is awesome. But they're very, very difficult to build, and you could never build an actual image with it. It would have to be more of an illustration. And animated GIFs, they are lossy at times, but typically lossless. They are limited to 256 colors, which is kind of a problem. They do have transparency in animations, though. So here's an example of some images. If I took this image, which has 1, 2, 3, 4, maybe 5 colors in it, a GIF would come out to be 17 kilobytes for the file. And that's, again, because they're typically limited to 256 colors. So that's going to come in really small. And we'll compare that to an image here in a little bit. A JPEG with no compression or a lossless is going to come in at 53 kilobit. But if we start compressing it down, it's going to be, you know, 33 or even less if I go down to a smaller file compression size. But it will have some JPEG artifacts. And I actually can see some around these corners that are very faint. PNG 8 come at 11. That's really small. That's great. And then this one 19. But again, they're low color counts, so we're doing okay. So here we go. SVGs come in as the smallest, and we can make this into an SVG because it's very simple. This illustration would be really easy to make. Now, if we're looking at a complex image, you can see how GIFs would come in really high. Okay, 426. That's significantly more. A JPEG without any compression is really high as well. But a JPEG with compression comes down significantly smaller than any of the others up here. So JPEGs definitely work pretty great here. PNG's 8 with limited colors. And you can see In some of these parts we have like some color problems. I don't know if you guys can see here, but again, we're limited to 256 colors, so it's not going to look perfect. It's going to look really degraded. But if we go to PNG 24, which it's not showing the example here, that would come through as a meg or 1.7 megs, which is pretty significant for a complex image. Now GIFs again are limited to 256 colors, so there are some images, some problems within the shirt that are going to come through. JPEGs are going to perform the best here, as you can see, at 410. PNG 8s are going to have some color problems, and if you use a 24-bit PNG, it's going to come in as a meg. So, and vector clearly won't work for this at all. Typically, this is the way I would tell you to do things. If you have a logo that you need some transparency behind and you need to make sure it looks good, use a PNG and make sure it's small. If you've got a photo of any sorts that has a lot of colors, it's okay, use a JPEG. That's going to be best. If you have something that can be illustrated and you're willing to put in the time, that might include a logo. An SVG is going to work great and be awesome. If you need something animated, go for the animated GIF. That's fine. I probably wouldn't use any WebP until it's supported by all browsers, but it might be in the future. It just depends if Apple and Microsoft decide to pick that up. The last thing I wanted to show is if you do have an image that is relatively large, go out here. Compressor.io is a great tool, but there's a lot of these if you look up JPEG compression tools. And this image right here, right there, there's the original. It's coming in at 700 KB. And after you run it through the compressor, you can see how it goes to 250. And as I move the slider back and forth, you can tell no literal image degradation on this, and things look fine. And so running it through a compressor after the fact will also help, and make the image smaller. As you guys make and design your final projects, I expect all JPEG imagery to be resized down to the size they intended to be on your screen. So don't give me some crazy huge high resolution image, but something smaller that will look good on the site, and then run it through a file compressor. Because if you don't, then you have a whole bunch of images that are all a meg or above to download. It really brings the site down to a grinding halt.